as shown by the graph below, so we need to recognize what these graphs look like. Okay, so the best way of doing this is sometimes by a process of elimination. Perhaps the easiest one to look at would be this one here. We can see it's an exponential graph, but it's a downward sloping exponential, so it's not going to be this one, it's going to be this one. So that would be graph E. The next one that may be the best one to look at is this one here. We know this is a reciprocal function where x is on the bottom, and there is actually only one where x is on the bottom, so it must be graph A. So it's not going to be this one here. So these are our other two. Hopefully you've recognized that because it's only above the graph, it's a modulus graph. If this had not been a modulus graph, it would be a straight line going down like this. We notice it crosses, or would have crossed, the y-axis down here at a negative value, which means it would have to be this equation, this graph here. So that would be D. And that's the easiest way of going through it. Alright, for the function 2 sine 3x, write down the amplitude. The amplitude is always given by the number in front here, it's 2. This affects the period, this 3, but it doesn't give you the period. So the period for a sine curve is usually 360. But whatever the value is here, we would then divide the 360 by that number, which gives us 120. Okay, single logs. So if we're writing a single log, we use log rules. If we're adding log statements, we would multiply the numbers. So that would be log of 6 times 3. So it would be log 18. We're then going to subtract log 2. So log 18 subtract log 2 means we're going to divide those values. So it's log of 18 divided by 2, which is log 9. Simplify these thirds. So always look for square numbers here. So 98 is 49 times 2. 50 would be 25 times 2, and 8 is root 4 times root 2. So you can see what I've done is change them each into expressions with root 2 in them. I know that the square root of 49 is 7 minus 5 plus 2. We treat them as though they are algebraic terms, so we would say 7 take away 5 is 2 plus 2, so the answer is 4 root 2. Another log question. So we know that if numbers are in the front of log, they can come up as their power, so we can rewrite this as log of 2 to the power 3. Similarly, this would be plus log of 3 to the power 2. That equals log k. So that's log of 2 cubed was 8 plus 3 squared is 9. Log 8 plus log 9, like we had up above, would be log of 72. Now notice here they're looking for the value of k, not the total answer. So the value of k in this case is just the 72. Find the value of log 25 over log 5. We're trying to make it as simple as possible, so we know that log 25 could be written as log of 5 squared. The 2 can come in the front, so it's 2 log 5. And then these cancel to give just an answer of 2. Next one, we have a trig graph. We're trying to find the values of a and b. We know that this number here is determined by the amplitude. So the amplitude of this graph is the half the total distance from top to bottom. So we can see this starts off at 4, ends at negative 4. So it gives you a total of 8. And half that distance would be 4. So A is 4. B is determined by the period of it, so we need to establish the period. The period is usually 360, but this period does a full cycle in just 180. So if we know it normally is 360, divide it by the actual period, gives us 2. So B is 2.